In this session, we want to discuss subnetting. Subnetting refers to the practice of dividing a network into two or more networks. Why would we want to do that? Well, we looked at the class A and we looked at the class B networks, and we saw that those networks had a considerable amount of hosts. The numbers were simply too large. When we have such a large network, we're going to have network congestion. So we want to take the large network and we want to subdivide it into networks or subnets. And that is what we do when we subnet a network. One of the topics in your course requirements is IP subnetting. IP subnetting involves the practice of dividing up your networks. In the process of dividing the networks, you need to be able to calculate the number of networks that you can have for a given network address. You need to be able to calculate the number of hosts in each network. You need to be able to calculate the subnet mask for a particular network, the IP address of that network, and the IP addresses of the nodes on that network. So let's say that we were given the address 192.168.5.4/27, and you were asked to, given this address, work out the number of subnets that you can have with that address and work out the number of hosts for each subnet. Now remember that if we had /24, that would say that the address has 24 bits, and that would be the network part of the address. And that would be a class C address. With a 24 notation, the default subnet mask would be 255.255.255.0. However, we were not given 24, we were given a 27 notation. And 27 notation means that the network part of the address has 27 bits, not 24. How do we work out the subnet mask for that network address? Well, simple. We already know that the class C address has 24 bits for the network part. So we need to find 3 more bits to make 27. What you do is you borrow the bits from the host section of the address. So where you have 8 bits here, you want to borrow 3 of the bits so that they are no longer host bits, they become network bits. So you have 24 plus 3 making 27. So that's how you get the 27. You borrow those 3 bits from the host. When you borrow the 3 bits from the host section, you are only left with 5 host bits. To calculate the subnet mask, you look at the section of the network that has the combination of ones and zeros. And that is the section you work out the subnet mask from. What you would have to do is you would take the binary number that you get, and this is a new binary number because remember before we had all zeros. But when we borrowed 3 bits, we changed 3 of the zeros to ones. So this binary number now is 1110000. All you have to do is to find out the decimal number for this binary number. And remember how we worked that out. We double the number starting from right to left. So 1, 2, 4, 8, 16, 32, 64, 128. And then we added the value of the ones, which would give us 128 plus 64 plus 32. That's the value of the ones. And that gave us what? 224. So the subnet mask for this address is now 255.255.255.224. Before, if we had a 24 here instead of a 27, the subnet mask would be the default subnet mask. But now it changes, and we see that the last octet now has a number of 224. So that's how we find out the subnet mask. After you borrow your bits, you look for the octet that has a combination of zeros and ones, and you find out the decimal equivalent for that octet, and that number gives you the number for your subnet mask. Now, how many subnets can you have given this network address 192.168.54/27? How do you find that out? Okay, there is a formula for that. What you do to find out the number of subnets that this address can carry is you look at the bits that were borrowed. And here, remember, we borrowed 3 bits? Right. So the formula for that is 2 to the number of the bits borrowed. So say 2 to the power of the bits borrowed. So if you had your scientific calculator, 2 to the power of 3 would give you 8. So we can safely say that if we have this network address 192.168.54/27, we can divide this network address into how many subnets? 8 subnets. Now you also have to figure out how many hosts you can get from one subnet. How many hosts will hold on one subnet? How do you figure that out? You take the number of hosts. And the number of hosts that we have here would be 5. Because remember, there were 8 bits originally. We borrowed 3. So now we have 5 left. To find out the number of hosts a network can carry for one network, you have to use a formula also. And the formula would be 2 to the number of host bits minus 2. And I'll explain to you later why we have to minus the 2. Right now, let's concentrate on the formula. 2 to the power of 5 minus 2. And that will give us 30 hosts. So you can look at your calculation, make sure that you do the calculation correct, and you will get the correct answer. Let's go over this one more time. You are given an address with a notation of 27. You're asked to find out what would be the subnet mask for this address. To find out that, you first have to find out the number of bits that you need to borrow. And we know that a Class C address is 25. So we already have the 25 here. We already have the 24 here, sorry, because the Class C address is 24. So you have 8, 8, 8. 8 threes are 24. But you need 27 bits. So you have to borrow 3 from the host part of the network. And it is those 3 bits that will help you work out how many networks you can have. Because the formula to configure the number of networks would be 2 to the power of the borrowed bits, which in our case is 2 to the power of 3, which will give you 8. And then you also have to figure out how many hosts you can have in each subnet. And to do that, you say 2 to the power of the number of host bits that are left back, which in our case was 5 minus 2. And that gives us our answer as to how many hosts you can have in each subnet. Let us look at another example. In this example, we're looking at a class B network where the default subnet is 255.255.0.0. The first 2 octets being the network part and the last 2 octets being the host part. The address that we've been given is 200.16.5.1/18. That means we're subnetting because the default would have been /16. And that would be the whole network. We want to divide up this network, so we give a notation of /18. So the first thing that we want to find out is what is the subnet mask for this network? How do you find out what the subnet mask is? You use the borrowed bits. So if the default is 16, we already have 16 subnet bits. To make 18, we have to borrow 2 from the host section. So if we borrow 2, we now have 16 plus 2 equal 18 network bits. So let's see how we work out the subnet mask. Remember, the formula is 2 to the power of the borrowed bits, and we borrowed 2 bits. So we could say 2 to the power of 2, which would give us 4 subnets. So right away, we know that on this network, we can have 4 subnets. Now, how do we figure out how many hosts you can have in each subnet? To figure out the hosts in each subnet, you have to look at the number of host bits that were left back. So we have 6 here because remember we borrowed 2, and then we have 8 over here. So that 6 and 8 will give us 14. So we actually have 14 host bits left back. To find out the number of hosts a network can carry, we would say 2 to the power of 14 minus 2. And that gives us 16,382 hosts. Then what about the subnet mask? Remember what I said. You look for the section of the network that has the combination of the ones and zeros, and you convert that section to decimal. So this is the first octet, this is the second octet, this is the third. So it's the third one we're going to be converting. So if you do what we said, you double from the left, from the right, going to the left. So it's 1, 2, 4, 8, 16, 32, 64, 128. And then you count the value of the 1. You would get 128 plus 64, which would give you 192. So that your subnet mask for this address is 255.255.192 Of course, you can always use the table, which I will give you after we've looked at the calculations. If you can memorize the table, then you will remember that 2 bits will be 192. 3 bits will be 224. But I'll give you that a little later. I want to make sure that you understand how to work out the number of bits so that you would get the subnet mask. So all you need to do, look in the octet, the section of the network that has a combination of the ones and zeros. Find out the binary, the decimal equivalent to the binary, and that answer will give you the number that you need for the subnet mask. We want to take a look at the Class A network, and we want to do some subnetting on this network. For the Class A network, remember that our default subnet mask is 255.0.0.0, the first part of the network being the network address. In our example, we're going to use the IP address 19.10.0.1 with a notation of 12. This is our network address. This is the subnet mask converted to binary. And what we need to do is to find out how many network bits we're going to get for this network. We already have 8. And to get 12, we have to borrow 4 from the host part of the network. And that is how we discover the subnet mask. If you take the section of the network that has the combination of ones and zeros, and you convert that binary to decimal, then you're going to get the number that you need for your subnet mask for this network. So we see here that we start from 1, and then we keep doubling as we go across. So 1, you double 1, you get 2, you double 2, you get 4, you double 4, you get 8. You double 8, you get 16. You double 16, you get 32. You double 32, you get 64. You double 64, you get 128. And if you were to add the values of the ones, you would come up with 240. So that would be 128 plus 64 plus 32 plus 16 would give you 240 for the second octet here. So the subnet mask for this address is now 255.240.0.0. And then we have to figure out how many subnets can we have for this network. How many subnets can hold in this network. And remember what the formula is. It will be 2 to the power of the borrowed bits. And we borrowed 4 bits. So it will be 2 to the power of 4, which would give us 16 subnets. Then we have to calculate how many hosts we can have on each subnet. And the formula for that would be 2 to the power of the number of hosts bits that remain minus 2. So if you calculate that, 2 to the power of 20, because there are 20 host bits remaining. Remember, we're left back with 4 here. Then we have 8 here in the third octet, and then we have another 8. There's 8 plus 8 equals 16, plus 4 equals 20. So to find out the number of hosts in each subnet will be 2 to the number of host bits, which was 2 to the power of 20 minus 2. In our next session, we want to look at how we would find out the network address for each subnet and the nodes within each subnet. That is the address of each node within a subnet. This is the end of our session, and we want to thank you for listening.